So what you can do to kind of help improve your short-term memory is that you can use a concept called chunking. And when you use chunking, you actually use a group of words and put them into phrases or sentences to help you remember information, right? You could be like fruit and apple, number and 5, but you can find ways to chunk information or to chunk data to help you with your short-term memory. So tiny bit more science. Talk about the lobes of the brain. So remember that cerebral cortex that I talked about, it covers or it blankets the brain. Well, it's split into 4 parts, which is your temporal lobe, your frontal lobe, your parietal lobe, and your occipital lobe. The temporal lobe, it holds your auditory cortex. And damage to the temporal lobe can result in a loss of hearing. So anybody who's lost their hearing, they have some temporal lobe damage. Were you doing that?
Yeah, I have some hearing loss. So I was saying,
Oh.
yeah. Go on.
We'll talk about hearing and attention a little bit later too. And then damage, again, to the temporal lobe can result in a loss of hearing. And then there's something called prosopagnosia, which can also happen when the temporal lobe is damaged. And what it does is it causes people not to be able to identify faces, which I'm sure you probably can't even imagine, but you're not able to identify faces, including your own face or faces of people who are familiar to you, people that you know. Then we have the occipital lobe. So the occipital lobe contains your visual cortex, and damage to your occipital lobe can cause blindness. The sensory systems that we talked about a little bit earlier, they're interconnected and they work together to achieve those high levels of cognition. So you've got now your 2 different lobes that we've talked about so far that can impact your hearing or your vision. And so if your hearing or your vision is impaired, then that is going to also affect how you learn things and your behavior and how learning that whole process, because again, it's a multi-level process, how that takes place. So you may be able to learn some things, but there are other things that you used to be able to learn or that you used to know that you won't be able to recall or do anymore. We have the frontal lobe. The frontal lobe receives information related to hearing and vision and touch and smell. So it's kind of powerful there. And it also is responsible for cognition, so learning functions. And we call it, again, because it is responsible for all of those things, hearing and vision and touch and smell, it's called the executive part of the brain. So almost like it's in charge. And then finally, on the lobe front, we have parietal lobes. Your parietal lobe houses the somatosensory cortex. So your perceptions of touch and taste and pressure and pain are all attributed to this part of the brain. So to sum that all up, you have stimuli that is received from the environment. So those things you hear, you see, you touch, you taste, you smell, they are converted into these electrical signals. And those signals are sent to the brain, and then those neural networks that we talked about, they transform those signals into words and sights and sound. And then it decodes what it means, because we can receive information and we don't always know what it means. Kind of like if you're reading Greek, like I can see the words on the paper, but I have no idea what that means. But your brain helps you to take that information and decode it, figure out the meaning, and then those systems in your brain produce reasoning and memory, like, okay, I know what this means. How can I use this to help me or to do X, Y, and Z? And then you have that memory of that you can retrieve later. That information is then also routed to other centers of the brain, because remember, just because something happens or generates in your visual cortex doesn't mean that it can't also be mapped to other areas to be very useful in those areas as well. And you take that whole picture, all of those things, and then you have a product, if you will, that you can act upon. So encoding actually refers to how you receive and cement that information into your long-term memory. A few methods that I have used, a few encoding methods that I have used are self-reference, generation effect, and organizing information. With the self-reference effect, connections are made to things that you're familiar with to help you remember information. So an example of that is when I was studying situational awareness, I would relate the different levels of awareness to how aware I would be of something if I had my eyeglasses on versus if I had my eyeglasses off. So I also took how well I could see something in the daylight versus how well I could see something at night. The generation effect occurs when you create information yourself as opposed to receiving and remembering information that you get from other people or from other sources. I use this concept when I create my own presentations and then deliver them to people like you and to different other audience. So each time I deliver a presentation, I'm not doing a canned presentation like, okay, this was the one I did last month. I'm most familiar with it. I'm talking about the same thing. It's a different audience, but I'm going to give them the same information. I don't do that. Every presentation that I do, I cater it to that particular message or that particular audience. And that helps me to continue learning, remember Michelangelo, and to also help you all to be able to learn, because the better that I know information, the better I'll be able to share it and then help you if you have any questions about it. So organizing information uses patterns of data arrangement to help us remember and retrieve it later. An example of how I use organizing information would be the way that I keep all information that is related to a specific topic in a certain folder. So it may be a topic like everything about human performance goes here, everything about root cause goes here, or maybe it might be a certain organization. So all of my Georgia transmission stuff goes in this folder and all of my other stuff goes in this other folder. But however that ends up happening, keeping all of that related information in one folder for easy retrieval, because I know everything for that particular thing is going to be there later. It helps me before I get ready to go to work on something so that I'm not trying to go and pull from a bunch of different places. I know that everything is in that one place. There are different types of attention. You have something called inattentional blindness, and that happens when you are unaware of stimuli that is clearly visible because you're not paying attention to it. So paying attention to one thing and not another thing happening in the same scene or in the same situation. And you can kind of go back to thinking about that situational awareness again. You see this one thing that's right in front of you. So, I see the house in front of me, but I don't see all the trees on fire all around me. So you're paying attention to one thing, but not other things that are in that same scene. Then you have something called inattentional deafness. So that happens when you're focusing on something. So you're looking at it and you're concentrating so hard that you actually can't hear things that are going on around you. So maybe you're in your office and you're working and your spouse and the kids are home from school and you're so busy concentrating on that thing that you're doing that you don't hear the kids screaming in the background or your spouse screaming at you to come and help them with the kids, right? So you're so focused on that one task that you don't hear things that are going on around you. And then there is something called selective attention. So that's attending to one thing while ignoring the others. So same example, I'm focused on my work, I don't hear the kids screaming and the spouse yelling at me in the background. I am choosing to or selecting to focus on my work right now. Then we have divided attention. So divided attention happens when you are paying attention to more than one thing at a time. And I'm sharing this with you, but I'm telling you, I don't necessarily like it because it makes people think that they can multitask. They kind of associate it with that. And there are only 2% of people in the world who can actually, seriously, honestly multitask. But divided attention, paying attention to more than one thing at a time. Then we have something called dichotic listening, and that's listening to something different in each ear. So maybe you have your webinar going on right now and you're listening to me talk, and maybe also at the same time you've got an earbud in and you're listening to music. So dichotic attention is you're listening to more than one thing at a time. They're in two different ears. And you can pay different levels of attention to things depending on what type of task you're doing. So if you're doing a low load task, which means you're doing something really easy, right? Like mopping the kitchen floor or something, then maybe I can also listen to music at the same time, or maybe watch TV at the same time, whatever that might be, because it's a low load task. It's something that's easy. But if you're doing a high load task or something that's pretty hard, then it's going to be a little bit more challenging for you to divide your attention if you are doing something that's hard, because that is going to increase your opportunity to make a mistake or to miss something that you really need to be paying attention to. Then we have something called change blindness. So change blindness happens when you have difficulty detecting that something in a scene has changed. So I use this example when I am talking to my system operators. So we have, I think it's like 12 by 18 is the size of the wall down in the control center. There's like 70 huge TV screens all put together so that they can see everything that's happening on our system. And each one of them has a different area that they're responsible for. So there's one person responsible for north, and one person responsible for central, and one person responsible for south. Well, that person in the north might be focused on their area, and that central person might come over and say, hey, I've got to step out for a second for a call. Can you keep an eye on the central over here? Well, that person might be so focused on their area, right? Because their area is north, that something could be happening over in the central where they were asked to watch out for, and they can't see it because their mind is focused exclusively and specifically on what's happening over in the north, so that when there's a change, when something happens somewhere else, they're not able to see it. And then there's something called scene schema. So that happens when you know what something is supposed to look like. So again, in my example with my system operators, like they're looking at this screen and they know what normal looks like, so that when something happens, and again, they're down there for like 12 hours a day, then they're not able to see it because they're so focused on that normal, okay, this is what the system should look like, and it's been looking this way for the past 10 hours. When something happens that at that 11th hour, they might miss it. So when a person is at attention, and we talked about all those different types and kinds of attention, they are better able to respond to different stimuli or different alerts from their environment. But if they're distracted or trying to divide their attention, then that causes our capacity for processing information to change. So we talked about low load and high load tasks. And whereas we would have been able to, if we were focused, to respond to things, if we're not focused, we're distracted or dividing our attention, then we're not able to. And I talked about attention spans. So we do have short attention spans. We are all forgetful. We are all distracted by whatever things we may be distracted by. And there was actually some research done by Wise Owl back in 2000. And back in 2000, the year 2000, the average attention span was 12 seconds. Well, fast forward 15 years to 2015, and the average attention span had actually decreased to 8.25 seconds. So that's less than a goldfish, because a goldfish has an attention span of 9